Greetings to all, and a warm welcome to our latest live webcast. Hatching ideas, mastering encryption and obfuscation with next-generation software protection. We're thrilled you've decided to join us for this enlightening masterclass. With each episode, we provide new highlights, technical tips, and success stories that will leave you inspired and ready to get your protection, licensing, and security techniques another step closer to perfection. At WIBU-SYSTEMS, we empower software publishers and intelligent device manufacturers with cutting-edge technologies, new business models, and tailor-made consulting training. Let us help you upgrade, optimize, and automate your entire license lifecycle management so you can focus on monetizing your business at a higher level. My name is Daniela Previtali, Global Marketing Director of WIBU-SYSTEMS, and I'm delighted to have you here with us today. We are joined by Rüdiger Kügler, VP Professional Services and Security Expert, and Axel Engelmann, R&D Software Team Lead Protection Technologies, both from the headquarters of WIBU-SYSTEMS. To give you a roadmap for today's session, here is what we'll be covering. Advanced encryption and obfuscation techniques for software protection. How AxProtector Time Protection CTP enables secure code modifications during compilation to prevent reverse engineering. Comparing this new solution with classic AxProtector and exploring its highlights. Full and modular application protection, operation without a license, CodeMoving for relocating executable code, advanced obfuscation options, and Computer Protection Suite runtime. Before we dive into the content, let's quickly address a few housekeeping items. For all of you tuning in today, we've set aside a special segment at the end of the session exclusively for Q&A. We warmly encourage you to drop your questions into the live chat box as they come to mind. If we can't get to your question during the live discussion, rest assured we'll make it a priority to engage with you individually at a later time to address your queries. This session is being recorded, and a link to the on-demand replay will be sent straight to your inbox within the next couple of days. This way you can revisit the insights shared today at your leisure. And don't forget, stick around for the entire live session and seize the opportunity to win an invaluable 4 hours of personalized commuter consultation with our industry-leading experts. As the webinar concludes, a new browser tab will automatically open, presenting you with a quick quiz. We'll randomly select a lucky winner from those who answer correctly and make the big announcement when we release the webinar replay. Kindly note that if you win, you'll be ineligible for any other prize draws we host in 2024. Be also aware that this brief questionnaire includes additional questions aimed at gauging the quality of this masterclass. While these questions are optional, your valuable feedback will empower us to enhance the quality of our offerings and tailor our online events more precisely to meet your specific needs. And now, without any more delay, I'm delighted to hand the reins over to Rüdiger. The stage is all yours.
Thank you very much for this introduction, Daniela. My name is Rüdiger Kügler, and together with my colleague Axel Engelmann, we will show you the next 50 minutes about AxProtector CTP, AxProtector Classic, and to compare about obfuscation and encryption technologies.
Hello, also from my side.
5 years ago, we had a big challenge. So with CodeMoving, we're offering tools to encrypt software, AxProtector. We offer this since multiple years, 20 years, even longer. If you consider WK-Crypt, which was the pre-version of AxProtector. And we have CodeMoving Runtime. CodeMoving Runtime is a service running in the background. CodeMoving Runtime needs to check if the license is there. So CodeMoving Runtime provides secure communication with dongles, secure communication in the network, retrieving information for fingerprints, secure communication to cloud license servers. So all the stuff is done by CodeMoving Runtime. And we wanted to improve the self-protection of CodeMoving Runtime. The challenge was, if you're using our own technology, AxProtector encrypts the executable. You need a license to start the executable, and CodeMoving Runtime needs to provide the license. So if we would use our own technology, we would need to have CodeMoving Runtime to provide a license for CodeMoving Runtime. So classical chicken and egg problem. And that's why we thought about, okay, well, how can we solve this solution? And then we took a look at the market and finding some products offering obfuscation technologies so that we can protect our CodeMoving runtime because it should run without having a license. And we found out there's no fitting tool which fulfills our requirements, which fulfills our security, the security level that we want to have. And that's when Axel and his team started to create a new technology which is a obfuscation technology, obfuscating, hiding, and a little bit encrypting CodeMoving executable. And so this was the first introduction of this technology. A couple of years later, a few customers approached us coming with exactly the same requirements. Our focus is protection against reverse engineering and not really licensing. Software should work even if there is no, or there should not be a license available. And we want to have the protection also if a license is there. And this was the birth of AxProtector CTP. Then we took our own technology that we developed for our CodeMoving runtime and put this to a product. And with AxProtector CTP, now we are offering a product which includes mainly obfuscation and a little bit encryption. And Axel, can you explain us the difference between encryption and obfuscation?
For sure. So as Rüdiger told you, we incorporate both techniques, but what does each technique do in detail? So encryption is mainly hiding program code by encrypting it and scrambling it and safeguarding it with a lock, basically. So the size of the application stays the same, and you need a key that you get the plain data from the cipher data. So it's not visible when you simply have it lying on your hard disk. Obfuscation, on the other hand, doesn't really change the code itself. It's still plain, but it makes it fairly more complex so that it looks like a maze. And it's not really that easy to see through it. So you really have to dig into all these different paths and all these complex operations to get the gist out of the program. And this is also why you see on the slide that the program is, for obfuscation, fairly bigger than the original one, or even compared to the encrypted one, since complexity comes from the expanding the program. It's not that you can get obfuscation with same program size. The security comes from the increasing complexity. But how is the security level of both techniques? And here we have to distinguish two use cases. And this is, on the one hand, when the code is not in use, like it's laying on the hard disk or it's not executed in the process memory, it's simply mapped. And we have the other scenario where the code is really in use and the processor really executes this code. And here you see that encryption is the best possible way to secure your code when the code is not in use. Because this is really security-proven techniques like AES, which give you the highest possible security. Obfuscation is here in the middle. It somehow depends on what technique is incorporated. And this is not really, it cannot really estimate, but it's in the middle. When the code is in use, it really needs to be plain for the processor. And here you see encryption doesn't give you any security at all because you have to execute plain code. On the other hand, obfuscation gives you nearly the same security level since code is plain, but it's only more complex. And this is why for AxProtector CTP, we try to give you a combination of both techniques. So what is AxProtector CTP? Yeah, it's basically a big dragon, since this is the animal from the LLVM compiler suite, which is the basis of CTP. And with this tool or with this new kind of protector, we also won the German Innovation Award in 2024. So let's look at CTP in detail. CTP stands for Compile Time Protection. As you see on the slide, we have different kinds of programming languages we support. In this case, it's C++, Rust, and in the future, there may also come Swift and other LLVM-based languages. And since we base on LLVM, we are free also for any backend which is used, like if we have Intel processors or ARM processors, anything which LLVM supports, do we also support with AxProtector CTP. Since we are basically a plugin to LLVM, which processes the intermediate code during compilation step. With the WIBU-SYSTEMS, we parameterize the protection, and in the end, you get a protected application which contains both obfuscated code and encrypted data. And this data, or this encrypted part, can also be bound to a CM container via the CPSRT, or you can also incorporate runtime protection features like debugger detection or anti-VM detection and so on with the help of the CPSRT runtime functions. So Rüdiger, how does the CTP compare against the AxProtector Classic?
If you take a look at AxProtector Classic or AxProtector, Classic is just the additional name, so to make sure that we have two different ones. And with the AxProtector, you take your source code. You compile your source code with your compiler. With your linker, you create your executable or your library, so DLL, shared object, dilib. And then you take AxProtector and transform the compiled application from an unprotected compiled application to a protected compiled application. So this is what the classic AxProtector does. AxProtector CTP is, as Axel mentioned, a plug-in in the compiler. And AxProtector CTP works in the same step. So when you compile your software, AxProtector CTP already obfuscates your application and maybe encrypt. I hope Axel will explain this. I'm sure Axel will explain this, and encrypt part of your application, and then the linker will build the final executable. So the big difference is the step where it is included. And Axel, there was already the first question in the chat. You said LLVM based and CLang or Clang. What if someone uses Microsoft Visual Studio?
Yeah, this is a good question, since Visual Studio is the main IDE for lots of people. And for sure, we also support integration into Visual Studio. It's basically a switch in the project where you pinpoint Visual Studio to use the Clang compiler in the backend for compilation step. But for your normal IDE work, it doesn't really depend which compiler is used. So you can integrate the CTP into any development environment you use. And this makes it also easy for the adoption in your environment. We also have an example in the CTP examples folder in the installation for Visual Studio. So you also see there how it can be integrated. Okay, let's take a little more in-depth look how we actually protect your application with CTP. But first, let's get some basics defined that we know how to or what we talk about in the future. So a function in compiler level or in compiler language consists of basic blocks, which is here defined by the balls. Then we have our links between the balls. Basically, these are jumps. And we also have some data or strings, which is here defined as T. So this is a very simple control flow graph. And each of these balls ends with a control flow changing function. This can be either a jump or this can also be a return like in the last ball. So how do we now protect this little control flow graph? We apply different obfuscation techniques. And as you see, not every ball is, or every basic block, is transformed by CTP. We try to select different basic blocks and then get some matrix or calculate some matrix and then apply different obfuscation techniques depending on what is actually done in each basic block. So as you see, the orange balls are obfuscated with different techniques. We also inserted some dead blocks. So these balls are not really necessary or relevant for function execution. They are only there to increase the complexity of the control flow. And the connection to these balls, especially to these dead blocks, are done by opaque predicates. So these are predicates which always evaluate to a predefined value, but this is not really visible from the program code. This is something which an attacker has to analyze over time. And we also see that the text, which was previously plain, is now marked here as a question mark, which means that this text or this data is encrypted. But how can we even increase the security of this control flow graph? And this is by control flow encryption. And this is a technique where we use control flow flattening and use introduce an indirection of each links, and this indirection is then stored in an address table. And here you see code is obfuscated and data is encrypted. So we don't alter any code during runtime. Code stays always the same. But the data, which is volatile data, can be changed during runtime. And this can also be linked to a CM license, which is here seen with the little lock and linked to CM. So depending on your use case, you can either have a completely self-contained application, which has no dependency to CodeMeter or any license, or you can even bind a CodeMeter license to this encrypted data. So we have best of both worlds, encryption and obfuscation. So let's have a look how a plain program looks like before it's getting obfuscated.
And this is something that even I, as a non-developer, can understand. So on the left-hand side, we have the original code. On the right-hand side, we have the disassembled code. Disassembled, I think this looks like IDA Pro. And so we see the stub code of the function. Something is loaded. Then there is check if this is 0. And then there is a jump if it is 0. The green arrow, the red arrow if it is not 0, and then there is this loop that you see on this large block on the right hand side. And so at the end I could analyze within a couple of minutes, maybe half an hour, what is the content of this function, and then it would be very clear for me, there's this Fibonacci calculation, and so this is not really protected, and so of course, it's unprotected, and so an attacker could guess or could find out the intellectual property in your source code. But Axel, how does it look like after AxProtector CTP?
Yeah, I give you the question back. Do you see anything which you can guess?
I see that there is a lot of pushes where something is pushed to the stack. I see there is some calls, but I don't see the dependency of the different blocks. So if you remember in the other case, there was an if the entrance word is 0, then go this way, otherwise take the loop and something like this. I don't see a loop. I don't see some logical structure. I see 7 blocks. Okay, but 7 blocks, this is not that much, Axel, or?
Yeah, you are right, but you have to keep in mind that the blocks you see at the top is only a small portion of the entire function. And here we have maybe like a little magnification glass. You see the function is in itself is really big, and it's shown below the big graph. So it's really expanded a lot, and an attacker really has to dig through all this code. And this is not encrypted code, this is plain code, but it's more complex, not easy to see through. So this incorporates a variety of obfuscation features.
There was a question in the chat Axel, already. What is the performance impact of CTP? If I see all this code, if I need to run to all this code, it looks for me like it is a huge impact, but I think we will cover this later.
Yeah, this is definitely a worth to ask question, since obfuscation isn't in nature slower, because we need to expand code, but we will give you an insight how to fine-tune your program to get performance impact up to only about 20% when you apply all these techniques which we will show you, so you don't get any more slower than around 20%.
And even if you see here that there is more code, it will not execute the complete code. The thing is that it will execute only a small part of the code, but it's not visible for the hacker which code is executed. So this is the trick.
Right.
So that's why it would not be, you see here the code is 100 times larger, but it will not go through the whole code. It will find the right path. And the trick is that the hacker could not see which is the right path which will be executed.
Exactly.
This is correct, yeah.
So let's see how CTP is applied to your existing project. We decided that we show you a CMake configuration, since most of C++ programs are set up with CMake, but in the examples you also see how this can be used for Rust. In the cargo build system, it's nearly the same kind of ease of use. But let's see, here we have our usual CMake line, we have Ninja build system, and we build for release type. We build our program with Ninja, and then we execute it with Hello World. So this is without protection, and let's see how CTP is incorporated in this. And it's only a few more lines. And here you see at the top, we defined our CEC and CXX compiler with the WIBU provided Clang and Clang++. We also have our compiler plugin, and this is the core of the AxProtector CTP. This is the WIBU-SYSTEMS. On macOS, it's a dilib, on Windows, it's a DLL, and on Linux, it's an SO file. Also, we have our protection specification, where you define what features you want to use for protecting your application, and this is done by setting the CTP YAML path. And all you need to do now is only to set the CXX flags and the C flags to the WIBU compiler plugin. In this case, it's the xclang, fparse plugin, and so on. So you don't really need to set up a variable for this. We only did this that looks a little bit nicer in the slide. And then you execute Ninja again, and you execute Hello World, and you have your ready protected program.
Two questions, Axel. On one hand, I see here build type release. Can I also do this for build type debug?
The CTP only obfuscates your program when it's built in the release mode, because we don't see any need to obfuscate programs in debug. And it also has another reason, because we execute compiler optimizations after we apply the obfuscation. And this is done because an attacker could also apply obfuscations on, could apply optimizations on an obfuscated binary, and then could strip out obfuscation techniques. And we want our obfuscation techniques to resist against these optimizations. So we optimize on our own with the well-known compiler optimizations in LLVM, and only techniques which are still present after this optimization are good obfuscation techniques. So this is the reason also why we only obfuscate in release mode, since we really want to give you the best obfuscation possible from WIBU.
Second question, I told you two questions, is you said something like the WIBU provided compiler, Clang compiler.
Yeah, we ship a ready built Clang and Rust compiler, since these binaries need to export symbols which can be used by the WIBU-SYSTEMS plugin. Usually these symbols are not exported when you download the compiler from the internet, but we simply downloaded the source code and compiled the programs with simple compile switches like export plugin symbols on LLVM, and then automatically these needed requirements are fulfilled for us. So in theory, or practically, you could also download the base Clang and base Rust compiler, compile it on your own, and then only use the WIBU-SYSTEMS with it. But for convenience, we want to provide you a ready-built package that you don't need to do anything on your own. You can simply start using it by defining these lines here, and then all is working. So it's more for convenience that we build it for you.
Okay, let's take a look at the features of AxProtector CTP. At the beginning, I told you that it was simply an obfuscation, advanced obfuscation for our own internal tools. But now we decided to have the same functionalities that you know from our classic AxProtector. And so if you take a look, we have the option of the automatic protection. Automatic protection means we have one executable, one library, DLL, dylib, shared object. And we say we want to protect this application with a CodeMeter license, firm code, product code. And then it should only work if the license is there. So this feature is available for AxProtector Classic and AxProtector CTP. Modular licensing means you have one executable, one DLL, and you want to protect different features, different functionalities in this executable DLLs with different licenses, different firm code, product code combinations. You can do the same with AxProtector Classic and AxProtector CTP. It's a little bit different from how you mark this in your application. I think Axel has an example in the next minutes to show you how to do this with CTP. With the Classic, you need to mark them as deckelspec DLL export or deckelspec WUPI deckelfunc, which is DLL export in the background, and of course no inlining. So with this, the modular licensing is available for Classic and for AxProtector CTP. That's a license-free mode. License-free means that it runs, or parts of the application work, can be executed without a CodeMeter license. So this is, for instance, if you have a freemium version, so that you say your software starts, but only a few functionalities can be purchased later, so the software is free. Or if it is a public software, which you give like a reader that can be freely distributed, but you want to make sure it is protected against reverse engineering, and then the license-free mode can be used together with this AxProtector CTP as well as AxProtector Classic. I would say one of our strongest protection mechanism is CodeMoving. CodeMoving means that some parts of the code will be moved from your application to the CodeMeter dongle or CodeMeter cloud container. So this is not available for a CMake license. It only works with cloud and the dongles. And then the code is executed inside the dongle, inside the cloud. And so it cannot be watched, checked by the attacker. And then the result of the code is returned back to your application. So this can be done with CTP, and it can be done with AxProtector Classic. So you see, it's nearly the same functionality. Also here, it is easier to define this CodeMoving with CTP than we had a webinar, I think 1.5 years ago, where we showed the CodeMoving for AxProtector Classic. There you need to do, or you needed to do a lot to define this CodeMoving function, to prepare it. And with CTP, this is easier to implement the CodeMoving. File encryption is also available for both AxProtector Classic and CTP. And file encryption means automatic encryption of configuration files like XML files, data that you want to read. Of course, file encryption can also be implemented manually with the CodeMeter core API, but this is definitely a topic of an additional webinar. And last but not least, advanced obfuscation. And this is the only feature which has a difference between CTP and AxProtector Classic, because this advanced obfuscation feature is a CTP only feature. And with the advanced obfuscation, we can do more than just the basic obfuscation that Axel showed you, and Axel will also show you more details about the advanced obfuscation in the next minutes. And so this is the difference between CTP and between AxProtector Classic. And for the other features, a few of them are easier to implement, especially CodeMoving with CTP. Automatic protection might be easier to implement with the AxProtector Classic because you take the executable, that's it. With CTP, you need to have the tool chain. The WUPI interface, so meaning checking licenses and activating, deactivating buttons or functionalities, is available for both. Error handling is the same for both. You can have the same CPS event for both. Features like traps and other security features are, of course, available for both. Also, anti-debugger detection, which is not written here, but also all the other well-known classic features are available for AxProtector CTP as well. And it's available for Windows, Mac, and Linux. Yeah. And I said, Axel will show you some samples. Maybe we start with the samples with the basic automatic protection.
Yeah, let's first also dig how do we configure these features, and this is done in the protection configuration. And as you see, the advanced configuration is simply a three-liner. It's only enabling code obfuscation, and if you want additionally licensing, you do it like you know from AxProtector Python, .NET, and JavaScript. You simply use your license lists and licenses, and then license list 0 means basic protection or automatic protection, and then it's linked, and all features which work from Python, JavaScript, and .NET also work for CTP. And now it's demo time, and I will show you how automatic and modular protection is done. And also we take a look how license-free is implemented. For this, I prepared some demos. And the first demo is automatic protection. And let's quickly see what the program looks like. Let's start at the main function. So we see that we should enter a value n, and we can also then choose a mode. In this case, for the entered value, we can calculate the Fibonacci number or the faculty. So we have a function Fibonacci, and we also have a function faculty. A fairly simple program with a little bit of arithmetic operations. So how can I specify my protection scheme to secure the application? In this case, I want to bind it to a license 6.10.13, and this is done by specifying the license and also specifying the license list with ID 0, because license ID 0 is always global protection.
This looks very similar to the file I saw from Python.
Right, it's exactly the same scheme. So our new vision is, if you know one product, you know them all. So this is all feature or future products will base on this YAML format in the WIBU-SYSTEMS. Now let's look at the CMake lists file, which defines how the project is built. And you see, it looks fairly simple. And here I put all the variables which were defined in the example before with the export commands in the CMake lists file itself. So I specify the C and the CXX compiler by setting it to the Clang CLX from the SDK path. I specify my YAML, in this case -d WIBU-CPL-CTP YAML path to the global CPS-Conf, which I showed you before. And I also define the WIBU-CTP DLL in the C and CXX flags. And this is your normal project configuration. In this case, it's simply the main CPP, which is defined for the executable calculate global. So let's see how the project is built. For this, we go into a folder, make a build dir.
Switch to the build dir.
And then we go, or we execute CMake. And here there's a little detail. We don't build with release. because usually when you normally build release on Windows, you don't get any debug symbols. So for this, we build release with debug info, so you also get the PDB file for later investigation when, let's say your program misbehaves on a customer system and you want to analyze some dumps, then it's helpful to have the PDB present. So this is why we build with rel with that info. Now we hit enter and we see the output shows us, compared to our usual CMake output using the Visual Studio toolchain, we are now using our Clang compiler. And here you also see a little detail. We ship Clang 18.1.7. So it's a pretty recent release with Clang. I know currently Clang 19 or LVM 19 is released. We will adapt this in the future and in more or less in the near future. So we are state of the art with our toolchain. So I think with the next release, we potentially are even or have even upgraded to 19.
But if I want to use a different version, I think it's worth to contact support and check what we can do, right?
Right. It's always good when you have some special configuration, simply contact us and we'll see how we can provide you the CTP for that LVM version. So now let's build the project with Ninja. It's getting compiled. And now we execute it. And here you see, maybe I make it a little bit larger also. Here you see that the license was not found. And this was our intention. We want to bind the application to a license. And since I didn't program the license to my dongle, the license missing error comes. So all as expected. Now let's program the license. And we all like to program licenses with BoxPGM, since it's fairly simple.
By the way, you can of course do the same with CodeMoving License Central and License Portal. Of course.
So now we programmed our license and we execute the application again. So let's now calculate, or we see that the application runs, and now let's calculate the Fibonacci number for 10, it's 55. I think it's good. And let's look at the CodeMoving CC in the bottom, and we see also that our license really is queried by the application. So let's execute it again. And now, yeah, 6. Fibonacci, okay. It's 8. And now also faculty.
6 should be 120.
For faculty?
Yeah, 6 faculty.
720. Maybe you should take the math class again.
Yeah.
So it seems to be working. Let's see, when I have a faculty of 4, it should be 24. Invalid modes inside. So 24 is correct. So we see application is working. But how would this application look like when I want to bind the faculty and the Fibonacci functions to different licenses? And here we have a separate example. It's the modular protection demo. And here we see the difference is we include now the WIBU-SYSTEMS.h, and we have an annotation, in this case a macro, WIBU-SYSTEMS encrypt with license list. For Fibonacci, we have chosen the license list ID 1, and for faculty, we have chosen 20. So you also see you can choose the IDs like you want. It's not needs to be contiguous. But when you use modular protection, it's best that you check the license availability before you execute any function of the license list. When you execute a function without calling check license and you don't have the license, the only way for the application to behave as expected is to halt. And this is when you use CPS events, because then you get the dialog and you have a message like license not found. Do you want to retry or do you want to cancel? And for us, the only possible way to have defined behavior is either wait or we terminate the process. And this is when you have a plugin scenario that you use the WUPI function, in this case CTP, check license, to also be able to react on scenarios where no license is there. So here I check the license before I call the Fibonacci function. In this case, it's license list 1. And for faculty, I check the license list with ID 20. So let's see how the modular protection configuration looks like. Oh, Rüdiger, do you have questions?
So by the way, if you compare this with the classic AxProtector, the WUPI check license is the same. So we also recommend there to implement the WUPI check license. And the difference is, instead of using this macro with the license list, you use a macro WUPI Deckelsperk func, and which export the function which should be protected. And the license list here is already defined inside the code, so it's more stable, reliable. And in case of the AxProtector Classic, the license list and the functions are associated in the configuration file outside, which means you need to make sure that it fits together. But here it's quite easy. You say check license 1, and then you're executing a function which has the macro or which has the attribute with the 1. And so I think it's more reliable if you do this here in this case.
Yeah. So let's look how the configuration file looks like. As we would expect it, we have 2 new license lists, Fibonacci and faculty, and also we have 2 new licenses, 6.10.14 and 6.10.15 for the different functions.
There could be gaps in the license list, right?
Right. This is because I have chosen by intention 2 different values that you are free what you want to use. So now let's also build this project. Make clear, build. Now we run it. For the initial step, it always takes a little time since we need to spawn a daemon and check license, but for all other translation units of a large project, it's getting pretty quick. So now let's execute the application. We can start it since we have the 6.10.13. Now we calculate Fibonacci, and now we get an error message. And this is the one which we specified in the source code, license not available, and we have the WUPI get last error code. So since you have modular licensing and you check the license on your own, you don't get the same message as before. You would use customized CPS events where you can handle all the licenses when you want to have defined values of which license is missing. Here you simply know what you do, and therefore we only return the error code 200, which is license missing. So let's program this license.
Maybe you can program already both.
Yeah, I do this. And now we see when we run the application, and also I make CodeMoving CC open. So 10.1. Now we query license 14. And if I use faculty 6, now we query license 15. So all is working as expected.
So usually if you would have a program like this, you would say, but I want to start a software as a freemium version, so without any protection. And that's why Axel has the next one prepared.
Yeah, and I only show you how the configuration looks like because the rest is the same. For the base license, and this would be the freemium case, you simply have type no license, and this is the license free mode. And then it's a self-contained application which has the freemium license embedded and can decrypt the stuff on its own.
I would also expect that markups in the C is exactly the same.
It's exactly the same as you see here, licenses 1 and 20. So the program doesn't change. It's exactly the same program, only a different protection configuration. So now we go on with our presentation, and I'll show you how automatic code moving works in theory. So here we have our control flow graph again. And what does automatic code moving do? it scans your function, or it scans functions for longest possible sequences which can be executed in an isolated fashion in an external environment. And here on the slide, you see that the little diamond was analyzed, and it's able to be extracted. So what automatic CodeMoving does, it removes this diamond from the control flow graph, encrypts it, and transfers it on demand when the application is executed to the CM container. This can either be CM dongle or CM cloud container, as Rüdiger told you before. So what does this mean? You can mark up nearly an unlimited number of functions which can be processed by CodeMoving. So these programs are not stored in the license and in the container. These are stored in a safe way in your application and then transferred on demand to the container. So for sure, this has a little impact on performance, but we tell you later on how you select useful functions there. But this is the most secure way you can protect your applications, by attributing single functions or multiple functions with the CodeMoving technique.
And this means that it's scalable. So you can select one CodeMoving function, but you can also select 10, 100, 1000.
Yeah.
You can have different programs, Excel, Word, PowerPoint, and you can say, I want to move codes of the different programs, different DLL. So that's flexible, and I think there's only this little disadvantage of the performance gap, but I think this is a good way to have it scalable.
Yeah.
If you take a look here, we see there is some basic encryption and encryption and some basic obfuscation. So this is, I told you, we have the features, AxProtector, so the CTP, automatic protection, modular protection, and so on. And the difference was the advanced obfuscation. So if we speak of all the mode without the advanced obfuscation, we're encrypting strings, we're encrypting constants, so quite easy and clear. And this jump indirection, where we have the address table that we jump from this block to another block. And so this is what we do in this basic mode, or with encryption and in the basic mode. And Axel, what includes the advanced obfuscation technology?
Yeah, there are some fancy words in there: instruction, substitution, call indirection, RTTI obfuscation, and so on. So these are well-known obfuscation techniques in the obfuscation area, and we also incorporate many of them. For example, call indirection unlinks the callee from the caller, or RTTI obfuscation scrambles the simple names in the meta information of your C++ meta system. And as I showed you before, the opaque predicates in that code complicates the control flow. So we have a variety of techniques, and they have different impact on performance and size. So like code virtualization is slower and makes code larger. Also, like function outlining increases the size, and so on. So we have different impact. And for this, you might question, what can I do about performance when I want to have high security? And for this, we have our automatic protection pipeline. It's fancy wording, but you basically can set it on par with profile-guided optimization. So this is a well-known term for program optimization, and we redefine it to profile-guided obfuscation. So we reuse this technique to give feedback to our obfuscator which functions are in a hot path, which functions are called more frequently or less frequently, and so on. So this is the execution profile, where you can run the CTP in a profiling mode, where this execution profile is generated, and then you can feedback this profile to the CTP to better understand the program and to better distribute obfuscation techniques. What we also do, we scan each function for different metrics. Does it has more operativity, so does it has more operational instructions, or is the integrity or integrability higher, so has it more calls or more control flow functions? And depending on this matrix, we then apply dedicated obfuscation techniques which really increase the complexity of the function in a useful way, and not only throwing anything we have on it and hoping it will do its best. So there's some intelligence inside it, which technique is applied and which not. And also we have a little protection model where we scan the names of the function and derive if a function is important and should be protected and is sensitive, or if the name implies that the function is basically a high performance function, and then we would not apply that much of obfuscation techniques on it. So we have our classification phase, which uses every information we get and then distributes, as you see on the far right, the transformations on the functions according to their relevance, importance, and to their frequency in use.
So I would call this AI-powered protection.
Yeah, this is a term which we should really take care of in the future. I think this is a good one. AI-powered protection is what the future is for CTP. So now let's quickly see how automatic code moving and advanced obfuscation is embedded into your application. I prepared again some demos for it, and as you would guess, it's exactly the same program, but differently protected. So let's first look at the program. What did change? Yeah, WIBU-SYSTEMS header is included again, for sure, since we need to have our macros available, but now we don't have CTP encrypt with license list, we have CodeMoving with license list, and we put this above each function, in this case Fibonacci and faculty. And I used here the same license list because it's more convenient. The security doesn't depend on it. I only want to show you that you can also use CodeMoving with license list 0. I removed the WIBU-check license because license is 0. Without the presence, the program wouldn't even run. So I can remove the checks. So what do I need to do in the protection specification? Not much, because previously for Python, and as you know from the classic AxProtector, you would need to define your CodeMoving functions with the source file, but this is not necessary since the source is already in your normal program. So the only thing we need to do is to specify the access password for the license which is used for CodeMoving. In this case, it's my password. And Rüdiger, can you quickly tell us how this is done in the License Central?
So yes, you can of course also do this in License Central. In case of License Central, there was a webinar where we showed you the configuration done by Jörg and me a couple of weeks ago. And there's a configuration that you can define that this advanced feature access password is shown, and then you can define it as a product item option. So what you need to configure first that it's shown, and then it is there, and then you can define it for your CodeMoving enabled license.
Great. So we also have the CodeMoving goodness in License Central. So now let's see how the CMake list looks like. It's exactly the same as before, only that we have our CodeMoving-CpsConf now as a configuration file. Okay, now let's build our program. Make deal, build. So we need to go into build. And then same procedure as every time, calling CMake. Ninja. Now it's building again. Okay, so now let's execute it. For sure, we need our license. Since I've chosen a different license, we need to program it first. And also in the license, the access password needs to be set. Okay, now we build our program, and now we call it. My favorite value is 10 and Fibonacci. And you see, it took quite some time. Let's do it again, but I still have the program open. Now it only takes 41 milliseconds. So this is what you need to take care of. CodeMoving has a little setup phase when you call a CodeMoving function at the very first time. So the whole infrastructure is set up in the background, but when it's set up, then the future calls are fast or more fast.
Can you also take the second one, the faculty? Does it also take for the first time of the second function that long, or is it fast?
Yeah, we look, it's fast. Since this is for the complete initialization for the CodeMoving. It's not for every function. It's only for the very first CodeMoving call. And we also see that CodeMoving does something. It's not only spitting out same numbers for, so let's say I have 30 and I want to calculate faculty. Okay, number is getting bigger. Let's try 40. And here you see it takes a little bit longer. So the CodeMoving really does something in the external hardware. It's not on your PC executed, it's executed in the CM container, and therefore also has some limitations.
I think Fibonacci would take more time than faculty.
Maybe we
can we check?
Maybe we tried.
No,
Fibonacci.
Well, quite interesting. But so if you take a look here at the 40 seconds or the 63 seconds, this is downloading the code to the dongle, decrypting the code inside of the dongle, executing the code, and delivering the answer back. So everything is included in this 40 to 60 seconds, in this case, depending on the performance.
And the avid viewer might also see something different from the initial CMake list, and this is the WIBU-SYSTEMS CodeMoving statistics variable. What does this mean? You can specify a CSV file. The location is up to you. You can put it anywhere. So the CTP then generates a comma-separated value file. And the intention for this is that you get a better feeling what function is eligible for CodeMoving and what not. So if you look at it, we have for each translation unit, since we have only one, in this case, we only have main CPP, a list of functions and with several values. So Fibonacci has 26, 1, 22, 22. And for you, the interesting values are the first value, so the first number, and the last number. There's also a little explanation in the how-to, which is located next to the CTP in the AxProtector installation folder. So the last value defines how many operational instructions the function has, and the first number specifies how many instructions and data can be extracted for CodeMoving. And here you see 26 is larger than 22, so we have all operational instructions covered and we have additional data. For faculty, we have covered all instructions for CodeMoving which are eligible in total. So these are good functions, since the first value is nearly the same or even higher than the last value. But when we now look at the main function, we have 47 instructions which are operational, but 0 could be extracted by automatic CodeMoving. So it doesn't make sense to attribute main with CodeMoving with license list, since no instructions can be extracted. And you also would get an error if you attribute a function and then nothing can be extracted. So it makes sense that you generate this file for your project and then select functions which have high first values, since the higher the first value, the better it is. Okay, so CodeMoving.
Can you just go back to the main CPP, the last one? So here we're using the CodeMoving attribute. Can we use the CodeMoving attribute and the modular licensing attribute? So can we have modular functions protected in the memory and having CodeMoving as well in one project?
Yeah, for sure. You also could have assigned this to licenses 20. Would also be possible. So you have a modular CodeMoving function, Fibonacci, but you can also use like encrypt with license list for faculty. In this case, I think it was 20 before.
So any combination is
Any combination
so
is
any
possible.
combination. So it's not an either or. I can use modular protection and CodeMoving and file encryption, and I guess also the advanced obfuscation. And maybe you can show us last but not least how to use the advanced obfuscation.
Yeah,
And maybe you should reveal this.
Yeah, I already did. So advanced obfuscation is pretty simple. You already saw it. This is why I only show you the WIBU-SYSTEMS. It's the 3-liner. It's only specified in the CMake list, and then program is compiled with it and it's obfuscated. So I don't need to show this, and it's simply working as expected, has no license binding.
But I can also combine this advanced obfuscation together with CodeMoving and license binding.
Yeah, for sure. This can also be combined. So let's head back to the presentation, since we have 2 little things to cover. And this is OS security. I told you before that code is not altered during runtime when the application is protected by CTP. And here we have like 2 flies with one catch. Since modern operating systems have memory protection features or memory security features. And especially Apple, with their Apple Silicon introduction and their hardened runtime, don't allow you to alter code during program execution, since the code is code signed and the OS finds any modifications and then terminates the program execution. Also, SE Linux has these features, and Microsoft for sure will, for some cases, introduce this feature. And with CTP, you are good to go, since no code is altered, so you are future-proven with these techniques. And we didn't have this in mind before, but it was a good thing, like 5 years ago, that we already had this in mind. And it's now paying off, and we can support all the stuff. So can you give us a little roundup, Rüdiger, what we learned so far?
Yeah, as a summary, what we learned is that when we encrypt code, it's very secure against attacks if the hacker has no license for the code which is encrypted. But if a hacker has a license, then he could have access to the code, of course. It is not that easy, as Axel mentioned at the beginning. You need to make memory dumps with at a lot of different times. You need to disassemble the code. You need to make sure that every function is used at least once. So it's not that easy. But in theory, it is possible to get a code. With obfuscation, even during runtime, the protection is still on the same level. So this was one of the first slides of Axel. And the operating systems, more and more operating systems like macOS and secure Linux gets hardened. And so changing code during runtime is something which is no longer state of the art. And so we don't change code during runtime. We only decrypt data and use the data then to execute the code in a way that it can be hardly analyzed. And of course, we can combine, as mentioned, code obfuscation with the data encryption, and this high integration is the key to a really high level of security. And the solution for this that we showed you today is AxProtector CTP compile time protection. And we think it's a future-proof mechanism because it relies on obfuscation and data encryption and no longer on code encryption. There is an automatic deep integration. We saw, especially with the CodeMoving, that we can do this very, very easy with attributes. We can also do the modular protection easier than with the classic AxProtector. And currently it's available for C, C++, Rust, and I think Swift will come soon, and Windows, Mac, and Linux operating systems.
Do you have any questions here, Rüdiger? I see some.
Yes, I have a lot of questions. And so the first question, I think we already answered. How much slower does the executable get? Or the second question was the performance impact. So I think we already answered with up to 20%, and depending on the mechanisms you select in this automatic fine-tuning. How much bigger does the executable get?
Diplomatic answer would be, it depends. But especially with advanced obfuscation, and when you attribute lots of functions, then the application really is getting bigger, and it's about a factor of 2, let's say. But since we have in the modern systems no memory issues or enough memory, it doesn't really has that of an impact. But if you care about embedded systems, it makes sense that you also only attribute your functions for obfuscation where you have really sensitive IP. So it doesn't make sense to have all obfuscation features for embedded hardware. So you simply go into the application and define some functions with WIBU apply obfuscation, and then CTP only obfuscates this function, and you can reduce your file size a lot and still maintain security. So this is something which we would advise for embedded applications where size matters. But in the end, using the automatic protection pipeline, you also get a good balance of size, performance, and security.
There was another question, Axel. What does the O0 in the makefile mean?
Yeah, the O0 stands for the debug or a non-optimized version. Basically an optimization level which is usually used for debug builds. But if you also have a release build with O0, then also the CTP wouldn't be applied. It's only applied when obfuscation or when optimization is enabled.
Another question was here, do I need CodeMoving runtime?
When you use, it depends, CodeMoving runtime and or CPSRT. So we have 3 scenarios. When you only use advanced obfuscation, then you don't have any link to the CPSRT and the CodeMoving runtime. If you use runtime features like debugger detection and integrity check and so on, you have a link to the CPSRT, but no link to CodeMoving. But if you really want to use licensing and have a license binding to the CM license, then of course you have the link to the CodeMoving runtime. So it depends on what scenario. Your only application is to secure your IP and you don't want any runtime checks and so on, simply obfuscating your binary, you don't need any obfuscation, any binding to CodeMoving there.
Another question, Axel, what is the possibility of future integration with C#? So is it possible to use this for .NET as well?
Yeah, this is something which is on our roadmap, but I can't give you any dates, but code obfuscation for .NET code, especially in the first phase, automatic CodeMoving for .NET code is something which we have on the roadmap and is something which we have an eye on it.
Okay, and the last question, I think I can answer this question. Which license do I need to use AxProtector CTP? We told you the difference between Classic and CTP, and you can use it with the same license. So you buy AxProtector for one target platform, Windows, Mac, or Linux, or maybe all 3. And then you buy them with the features, let's say with the modular protection and CodeMoving, and then you can decide if you want to use the AxProtector Classic on the executable or DLL, or if you want to integrate this into your toolchain and your build process, so in the compiler using AxProtector CTP. So it's the same license, and you can decide which one to use. And I told you the only difference is the advanced obfuscation. And that's why there's a feature, the compile time obfuscation CTO. And so with the CTP, compile time protection, you have the additional option, CTO. And if you want to use this additional advanced obfuscation, then you need to purchase the additional license for this advanced obfuscation, compile time, obfuscation license. This is the only difference, but all the rest, it's the same license for Classic and for CTP for the same functionality.
Okay, that was all, I see. And so I have to thank you, and I hope to see you again in the next webinar, and stay safe at best with our technologies.
Yeah, same for me. Bye-bye.